Hello, welcome to the Cosmic Shambles Sunday Science Q&A, which we have generally been here every Sunday at 3 o'clock since lockdown. The only times we haven't is when we were doing our Albert Hall gig, which is still online, the Sea Shambles gig, and also the Cheltenham Science Festival gig. So thank you very much for joining us again. This is kind of predominantly going to be about engineering, which is great because it's one of the things, certainly with Monkey Cage, we often get complaints that we don't do enough stuff about engineering. And we have people who their knowledge of not merely the future possibilities, the current possibilities, but also some very, very beautiful things that I've been reading as well about the ingenuity in whether it was the Brooklyn Bridge or the Great Wall of China, etc. We're going to be talking about a lot of different things. We have your questions. Thank you very much, everyone who's sent in questions. If you have a question during the show, you can just send it and we will pick that up. That's on the live Q&A. Trent will find that. Trent, who produces all these shows. A few things to tell you. One is our Patreon. We're still making about 6 or 7 shows a week, and Patreon is one of the ways that we basically was the main way that we're actually able to keep making shows, especially at this point where most of us don't have. Certainly for someone like me, I was meant to be on tour. I'm meant to be doing an enormous number of live gigs. I've got my set that I was going to be doing at Glastonbury, and it's going to be great weather as well, thanks and everything. For a lot of the live entertainers as well that we have on, we use our Patreon as a funder. There is also a tip jar if you can't be bothered to do the Patreon thing. That's at the bottom somewhere on your screen. You will find that. And Josie Long is doing her tender show tonight at 8:30. She's going to do a live stream of that. And I will also mention we're doing a series, a genetics shambles series with some of you saw we did a COVID-19 Q&A the other day, and that's kind of almost the starting point. We're working with the Milner Centre for Evolution and the Genetics Society, and we're going to be doing a series about various different issues and understandings of genetics, and that's going to be over the next few weeks. I'm also going to mention, because I am wearing, I don't know if you can see it, I think I've got a bad angle today. Let me just see if you can see. Can you see my t-shirt? That is Bill Oddie, the wonderful Bill Oddie from the Slapstick Festival when I was with Bill. And that's reminded me of orangutans, because the first time I met Bill, we were both dressed as orangutans. And that was because we were doing something for Orangutan SOS. And go and look up Orangutan SOS. They are a fantastic charity. And on the 30th of June, I'm doing a live stream quiz to try and raise money for them as well. So if you can join that, that's great. Right, let's get on with it. That's everything dealt with. First of all, let us meet every single week, because she knows about everything. It is pretty much, you've not done badly, Helen Czerski. I've got to say, you have your... every now and again you have those moments that people love seeing with Brian Cox, which is when I did the long tour with him. Every now and again there was a question I would throw at him and he'd go, I don't know, and there'd be a tremendous sense of relief. And I think that's happened even less with you. I think the don't knows have been very, very rare. So Helen, how are you?
I'm all right. Yes, so because, as you have mentioned before, I've been did a bit of moving around, been tidying up, and I found I own more interesting things than I thought. And what's really nice is that my room, especially my living room, now looks like a museum. It's brilliant because I've decided to no more of things going in boxes. They are all going to go everywhere. So it looks like a combination of a toy box and something like the Sloane Museum. It's great.
Oh, that's fantastic. As you know, I'm a big fan of everywhere. I think I'm particularly everywhere at the moment.
We haven't seen your floor before. That's in all the piles of books.
Yeah, the floor's a new one because I thought I don't like being lazy. I don't like not having enough to do. So I've now started book selling as well. I thought now I can't buy books. I still want to have a relationship with books, and so instead I'm selling them. Because I have got too many. I have to admit that.
Are you admitting that? How many years has it taken to admit that?
Well, every now and again I admit it, and then I reverse into denial. So I'm just going to see how long until denial kicks in. What is your show and tell today then? Is this something you discovered while you were going, I'd forgotten I had this?
Now it's a bit hard to see. I'm going to show it you from far away. Let's see. So now the bit you'll probably be able to read is the bit at the bottom. It is a bit faint. I'll tell you what it is in a second. And you should be able to see kind of pencil lines.
Yes, can see that at the top. Yes.
Pencil lines here. We're doing a bit of a scan down. And what you can see is the side of an H. So this is a font H. I'm going to hold it back, but it's a great big thing. It's this big. I'm going to put it down and tell you what it is. And where it's from is, I grew up in South Manchester, and one of the, when you grow up, there's things nearby and you don't realise that that's a special place. You just assume everyone's got one. And one of the things that was very close to me was the linotype factory. Now, anyone who knows about design gets very excited about the linotype factory, but they were a printing factory and they designed a lot of early fonts. So where it says Paragon italic down on the bottom there, this is the original design drawing for the 8-point Paragon. If you look down your fonts on your computer now, you will see Paragon on there, and it's got all it's a shame I can't show you because it's glass, it's quite hard, it's reflective, but there's all these little measurements, all the careful someone really thought about this H. And when the linotype factory, so they had all these design drawings, and I was taken there on school trips and shown the printers where they printed the yellow and then they printed the red and then they printed the blue, and it was this massive thing. And when the linotype, it's actually, I've just noticed the back, it's got, this is the official thing, the original master drawing. So when the linotype factory finally closed about 10 years ago, I think, my mum noticed they were selling off letters, and so she bought me the letter H for my birthday, but it is the original design drawing of Paragon 8-point font italic letter H. And I just think it's really nice that design of the past still exists in these paper forms, and that fonts are things we don't really think about. But obviously there's lots of different ones, but someone had to spend a lot of time with a piece of pencil kind of rubbing bits out and lining things up. And it's really nice to have a kind of paper record of that. So yeah, that's my show and tell.
I think that's beautiful. I think that is, again, an example of if you look at anything for long enough, you will find something in it. And I always find that, by the way, I hope you use that font size for every letter that you ever write. But it is, it's just that I used to do that in hotel rooms. A lot of the budget hotel rooms that I stay on tour, I really start to look at, like, carpets in particular. When you go, how did this design occur? I've actually, when I did the tour with Brian, I took a photo of every single, we stayed in whatever, I think 88 hotels in the end, because we went around the world, and every single one I took a picture of the carpet in the corridor and going, why did they go with this design, and who went with those swirls? And I think that is, everything looked at for long enough comes alive. And that is beautiful. And
there's character, there's humans. Even though the whole point of a font in a way is to be impersonal, there was a human behind it, and the signature of those people carries on, even though we don't get to hear about them.
Yeah, I love that. Every time I think there were meetings over the letter H. We are also joined today by Lisa Rogers. It's lovely to have you. I saw you as Christmas at the 9 Lesson Show. And what have you been up to in terms of your creative ingenuity during lockdown?
All sorts of stuff, but in particular, the Design Spark podcast has been released during lockdown. That's where I get together with a couple of comedians, Beck Hill and Harriet Brain, and we look at the funny side of technology. So that's been was a really fun one to do. So I've enjoyed that.
Beck's great. What's the hardest? Because I think, people do have this strange relationship with technologies. We have so much around us. So much of it is magical because we are unable to repair it. It's not like when our parents had a tool shed or a workshop. What has been so far?
You might not be able to repair it.
No, well, yeah, that's it. You need to be a specialist. You can't get, my dad didn't have any, but you could take something apart and you could go, oh, it's that screw there. Whereas now, I look at my laptop or my phone or any of these things, and it's sealed. It's almost designed to not be repaired by someone as stupid as me. What's been the hardest thing doing the podcast of going, right, I think, this to people's eyes is merely something that infuriates or is problematic. How do we, like that letter H, bring out the joy of this piece of technology?
Well, we did an episode on quantum computing. Now, that was just, that's hard for the people who are working in it to explain to each other, let alone to anyone who hasn't got an in-depth knowledge of it. So that was a really challenging one. But we always managed to find some kind of analogy, and that's how it works. Beck always finds a way that it could be done bigger or better, and obviously in a Beck Hill type of way, in a very funny way. And Harriet Brain has been looking at some of the historical characters and the historical inventions, as well as forecasting things. So she's been putting that in a musical context. So we've managed to take different ways of looking at it and actually put that together in hopefully something that we can call entertainment, but actually just slips a little bit of science in there to everybody's knowledge.
Yeah, I think it's an interesting thing, isn't it, that so many people don't think that they've got scientific brains, but of course they've all got curiosity. It's just that you have to, sometimes it's harder to lead them to it, and then they go, oh, I've just realized this is, and then once you've done that, then every object they look at, like I hope today, everyone's going to be, if they pick up a sheet with anything, and they'll just think, oh yeah, let's just look at the H on that, and let's look at that. What is your show and tell today?
Oh, well, I usually geeky things such as my nodding dinosaur, but I have gone actually for this box. I've inherited this box from my granddad. My granddad was a clockmaker, but he also made he did up veteran cars, rebuilt veteran cars, and a steam engine, a steamboat. So I acquired this box of goodies. And so we've got a whole selection. I'll put the box down. A whole selection of... Go on, what are they?
Oh, I do. It reminds me of the Pink Floyd The Wall illustrations by Gerald Scarfe.
Are they something for chains, like, bike chains, large versions of bike chains?
No.
Oh, go on then.
Tiny. There's that. There's a blade in there that rolls. They're glass cutters.
Oh wow!
For cutting glass. And then I assume you put your glass in those bits and snap. That's what I'm thinking those are. And it's taken me a while. I put this one on Twitter. You know what that is?
Wow, no, I've got.
What is it? It looks like the stick you use to poke things out of annoying holes.
Similar. It's hollow.
Is it for ink, like a pen?
It's a porcupine quill.
Wow.
And
beautiful.
It was used, I think, in this box. It's amongst some lace making stuff, and I know that spinners use it for getting some of the wool out of the carding when they rip the wool apart to make it all the same way. So that's good. And then this one is probably my favourite.
Oh. Well, come on, Helen. I told everyone beforehand you always knew everything.
It's a little clamp, right? It's a little clamp for holding rods or something.
I'm assuming it's a test tube clamp.
Oh, yeah.
But I'm not sure. I'm just making that assumption because sadly Grandad's not here anymore to ask him what all these tools and things are. I've got loads of things and lovely keys.
But what's amazing about all of that is how valuable tools are. Like, we kind of forget. You can go to wherever, Homebase or B&Q or whatever, and you buy a tool, and you forget that it wasn't that long ago that the set of tools, like if you were an apprentice, the day you got your tools or had to make your own tools, go further back, that was the most symbolic thing. It wasn't just that you had the knowledge to make it, it's that you also had the tools to do the job. And it was such a precious thing. It's actually something that my department, because I work in an engineering department, even though I wind them up regularly by reminding them I'm not an engineer, that we're trying to bring back to our students actually is to give them a toolbox at the start.
Wonderful.
So they have a toolbox, because people have sort of forgotten that you need so many tools are online, but actually if you want to understand things, the physical nature of things, you need things like that, and they're beautiful and they last. How old are they? Do you know?
No idea. But yeah, brass stuff they stopped making brass stuff a long time ago.
Right, this has now inspired me. I've suddenly realised I can't believe don't think I've got them here. I used to get, every time I went up to Newcastle, Dan, who's a guy who came to my gigs, would give me a different late 19th century box of slides of different diseases. From the 19, all of them with this incredible little, very fine handwriting, all of which is, and I was amazed I was allowed to take it on as hand luggage. So I had a huge box with all manner of lung diseases and different forms of kind of, small samples of tumours. What have you got there?
That kind of slide, you mean?
Oh, is that Newton in that one?
Yeah.
Yeah. Oh, that's but really, I mean, literally with a small cell sample of.
Yes.
Yeah, so break in emergency should this
so
pandemic not pick up enough.
The customs form that says, "Are you bringing any infected material into the country?"
Oh, well, I've only taken them from Aberdeen to London. I will see if I can get them into Sydney or Singapore the next time I'm allowed to go there. So we'll keep that up as a test. Brilliant, Lucy. We're gonna that was a lovely. What I loved was seeing, because you said there your grandfather worked on a steamship, and thinking of the lace work that he did on it, and also the window work, because that seemed because I thought that might not be test tubes. I thought it might actually be part of the curtain rail for the lovely lace curtains after he cut the windows out. So it's a beautiful story of that particular steamship. We're also joined by Roma Agrawal, who has written a wonderful book called Built, which is looking. Well, I'll start off first of all, Roma, with. You were very good. Keep that. You're meant to have found that stand that everyone has when they're on Newsnight, where their book is just right behind them. But you started. I mean, you were 23 years old when you were working on the Shard. Is that right?
22. Well, yeah, 2022 was my 22nd birthday. Was my first day of work as a structural engineer, and then I started working on the Shard.
I mean, that's a remarkable kind of early project, isn't it? What was your? How did that come about? How did your involvement start with that?
So Helen, I've actually got a physics degree, so I'm kind of part engineer, part physicist. I don't know.
Invading the engineer's territory. That's what it all was. Taking over by stealth. Lucy shaking her head.
Probably get rejected by both sides, actually. But yeah, so I studied physics, went on to do a master's in engineering, got a job.
You're forgiven now.
No.
You've done the master's, that's fine.
So I did do a master's in engineering, and then I joined a company, and the first ever project that I worked on was actually a footbridge, which is in Newcastle, and it joins up two different bits of the Northumbria University. So, when students wake up in the morning, they don't have to walk for like 15 minutes to get to lectures. They can just cross the one bridge. And I mean, we all know how important sleep is for our students. So, changing the world over there. And then the second project I got to work on was the Shard. And I mean, basically, it was because my boss was a good engineer, and he was asked, "Do you want to work on the Shard?" And he said, "Yeah, that will do." And he came to me and said, "Do you fancy working on the Shard?" And I was like, "Yeah, okay, yeah, that would be all right." Super cool.
So I'm always as a kid, I used to love those books which would have the cross sections. It would be a cross section of the ships and buildings and all manner of things. And for you now, the Shard is one of the most famous contemporary landmarks of London. So when you look at it, do you have almost a moment where you can zoom in and you get a sense of some of those details that you were working on? You have a different sense of that structure, I would imagine, to someone like me looking at it.
Definitely. I mean, I always joke that when I go up to the viewing gallery, forget St. Paul's, forget the Thames, forget all the views that all the tourists are taking photographs up. What you need to do is to look up, because if you look up, you can see all these welds and bolts and connections between steel beams, and you can find there's 5 cradles up there which I used to clean the windows, which you can spot as well if you're being observant, and you can even almost deconstruct how we assembled the spire, which is the top bit of the building, if you can see like where the seams are between the beams and stuff, and that's really what I love looking at. So I always joke that you can tell who the engineers are when you're up in the viewing gallery, because we're all kind of looking up at the steel.
And when did you get that sense of, having, as you said, studied physics? When did you realise that engineering, was it something you had known for a long time, that fascination with structure and creativity, was that always?
So no, it was the opposite. I actually had no idea what I wanted to do, and that's why I studied physics. And I'm sure Helen will agree that you study physics and you can do anything. I mean, you can almost do any career with a maths or a physics degree. And that's what I did. And then I was trying to earn some money one summer, and I had an incredibly boring job. So I was sitting in the Oxford physics department and basically drawing up where all the fire alarms were and the fire extinguishers were, and basically like almost doing a survey. So boring, important, boring. But I was surrounded by engineers, and those engineers were designing the equipment that was going into CERN, so big particle accelerator in Europe. And it kind of blew my mind, because I suddenly realized that engineering was this thing where you use maths and science and physics to make stuff. And I think that's what I needed. Is I needed that kind of that real stuff thing. And then that's where the inner engineer really comes out and leaves the physicist behind, perhaps, is that I wanted things that I could hold and point at when I finished a project. So went into engineering from there.
I was once at I haven't been up the Shard very often, sorry to admit that. One time I did go to one of those, is there bars or something up there? And my friend, you can see the Tower of London. And my friend who was with me looked down and he said, 1,000 years ago, the Tower of London was the Shard of its day. And that sort of zoom out, and you suddenly think in 1,000 years' time, is there going to be another, probably less than that, but another great big thing, which is even more, and they'll look down on the Shard and go, oh, well, wasn't that nice when they could only bolt everything together with little hooks for where the window cleaners are going to go.
When they look down on Earth.
Yeah.
That's interesting, because when we had Sarah Parkak on a few weeks ago, and she's been on Monkey Cage since then, and I did a chat with her. She does fantastic work of basically images that are taken from space, and the way that we're now able to detect the structures and detect where in a way that you cannot do actually on Earth. You need that distance and that technology. And she was talking about how much she loves as an archaeologist going into certain temples where you discover that they're a palimpsest, that this has always been a holy place for very often different religions and different beliefs, but things are built and built on and built on and built on, and as you you find that structures that are overwritten. And I think there's a real joy, which we won't have now, will we? I presume that everything, the modern things, will merely it'll be knocked down and started again. We won't have that same sense of, when you go to a church and you go, oh my God, so that bit's from the 10th century, that bit's from the 12th century. Then Cromwell went and smashed up all those stained glass windows. So then that was put in.
Have you ever read any computer code? That seems to be this bit was from this bit was from then.
So that almost becomes DNA, doesn't
delete, it? Yeah.
It's interesting because the Shard, in a way, did that to an extent, because whenever you're building in really urban places, London, on one hand, building the Shard in the middle of a nice big field with nice rock underneath would have been much, much easier, even though you still need to make the structure and the skeleton itself stand up. But what we were doing in central London was weaving the Shard between a 1960s apartment block, the 50s to 60s bus station, the tube line that ran across, and then an 1800s set of brick viaducts. And then we had a listed train station as well. And then there was a hospital across the street. And so the Shard actually has interfaces with all these different old structures, which are quite woven together. And, in 1,000 years, if someone wants to take the Shard down, it's actually a bit of a puzzle to, unwind all those things back. So I think in some senses, you will still retain an element of that combination of eras.
So I got a sense there that you still work for the same company that built the Shard, just because you went, what shall I use as a time frame? 1,000 years. The Shard will definitely, the guarantee that we wrote on that building is still 1,000 years. We have loads of questions for people. I'm going to start off with Lucy, with you actually, but everyone do chip in if you feel. This is from Rose, and this is because I was thinking that you are someone who's you build lots of different things using batteries and all manner of different kind of ways to power things. Rose would like to know, I appreciate this is a very broad question, but why aren't batteries better? Why can't we have a car battery that holds charge longer? Why does my phone always die?
It's chemistry. It's all down to chemistry. We have to try and get energy from one thing stored as another thing, and then we can actually use it. That's basically what a battery is. And an analogy for that is the food we eat. The food I eat, chocolate, goes straight onto my hips, and I can use it later for energy. And that's effectively what a battery does. It takes energy, electrical energy from somehow, stores it in chemical energy, and then releases it again in electrical energy. But every time we go from one thing to another thing, one type of energy to another type of energy, we actually lose energy. We haven't got 100% efficiency. And so every time we do those jumps, we lose something. So that, you might put 100 whatevers in, but only get 50 out in the end. And it's just all to do with how we can store that, where we can store it, and the storage takes space. So batteries are big. When we find different chemicals that we can use, so the lithium ion batteries are actually smaller than some of the alkaline batteries, and we can change the shape, get it smaller, get them more dense, but still we've got those conversions to do.
So there is some basic chemistry there, but one of the interesting things about batteries is that you could make them so they're quite constrained. What you don't want is, so the one thing is, can the atoms do the job? Can the atoms and molecules store energy, and can you move it about? But then you get to the question of, can they do it safely? Like, if you want to dump a load of energy really quickly, is this battery going to expand and get hot and crack everything and explode? Is it going to degrade over time so that you can use it twice, but then it stops working? Is it going to, if it heats up because it's a slightly warmer day, is it going to start reacting with itself? So actually, and also the speed at which you can put energy in and take it out are quite big constraints. So the chemistry itself is one constraint, but actually, if you speak to most battery manufacturers now, what they're doing is putting a lot of effort into testing, cycling batteries through charge, discharge, heat it up a bit, do it when it's hot, do it when it's cold. And what you find is that a lot of the potential battery technologies, the chemistry looks like it will work, but when you actually get down to the engineering, like how do we put it in a device? Is it safe? Is it going to be used lots of times without exploding? It gets quite a lot harder. So there are some really promising types of chemistry that are very different, completely different recipes coming down the line, but there's a few problems to solve to stop them, to make them reliable and to make them cheap. So it's a huge grey area. Sorry to jump in there, but it is like there are constraints on batteries, which is you want them not to cause problems.
So I have a random, I don't remember the names of all the scientists and stuff, but they thought that electrical currents, they could get frog legs to twitch, and they thought that animals themselves were creating some kind of animal electricity. And then there was a scientist called Volta who kind of proved that this wasn't the case. And he figured out that if you had two different types of metal and they were separated by something moist, we love the word moist, don't we? And he tested this by having two different metals on his tongue. And then he could tell that there was a current going past because he'd get funny tastes in his mouth. And that's how he figured out that he needed to do this. And so he layered two different types of metals, and I can't remember what they were, separated by wet cloth, and he built this up in a big stack, and that was the first ever battery. So when we talk about the voltage of a battery, that's from Mr. Volta.
And the battery architecture is basically exactly the same today. It's layers of anodes and cathodes, the two ends of a circuit, with some kind of moist layer in between them. So basically his original idea really hasn't changed that much.
We realise they're hearing these stories that, you do know that you've got a young scientist in the family the moment they start licking batteries, just to find out, yeah. So that is that level of ingenuity is the start of a scientific curiosity. I once put a pin into a plug socket. Didn't end up well. Dan has a question. I'm going to start with you on this one, Roma. This is Dan. Has anything like the famous illustration of the misaligned bridge parts ever happened in real life? So that moment of building an enormous bridge and then going, they don't meet in the middle. Do we see real life examples of that?
Well, so this didn't happen on the Channel Tunnel, but I guess that was an example where it could have happened because, we had the French and the English engineers almost working simultaneously and coming to each other. The reason that doesn't happen is because we can monitor things so well now. So we use, on this particular tunnels, we use these giant machines called tunnel boring machines. And it's basically like a big cylinder which chops rock out and it moves forward, and then you line the tunnel behind it to create the tunnel. But you can measure the XYZ coordinates, its position in space in all its different degrees of freedom. So as you're digging, you might kind of go off course a little bit, but you can always then correct it in time for when you meet. And so I think that's one of the amazing things about modern technology is just that ability to monitor things in real time, using lasers, using GPS trackers, getting tons and tons of data into computers, and then computers basically be able to sift it all, make sense of it and say, yep, it's going to work, or oops, we're going a bit off. That means that hopefully that sort of thing doesn't happen anymore.
Well, hopefully we'll have time as well before the end to talk about. I know one of your favourite bridges is the Brooklyn Bridge, and we will come back to that.
But actually, Robin, can I just say one more thing? Because I did actually bring a show and tell.
Oh my goodness, we forgot that we counted the book as a show and tell in error.
That's fine. So this is a piece of aluminium which is actually used in buildings like the Shard, which get cast into the concrete floors. So the top of the concrete floor would be up at this line. And then what you have here is basically a nut and bolt with a plate which you can shift side to side. And the reason that this is built in is because you're casting this into concrete. So, it might go a few millimeters off where it should be. And then when you come in to hang the glass of the skyscraper much later, you then have a little bit of adjustment that you can make here so that you can get the sheets of glass all lined up. So again, that's like a little bit of engineering which has been designed to make sure that misalignment type situation doesn't happen.
Now, in your book, you wrote also the Great Wall of China. What was it they used in that, again, to get that so that there was some sense of malleability in the structure?
They used rice in the mix for the grout. So, parts of the Great Wall of China are made from these large bits of stone. And, when you lay bricks, you put mortar between that. So it's a similar principle. But what that mortar is made of can really, really vary from country to country, civilization to civilization. So the Chinese put, and this is what they think they've proved by doing tests on the mortar, sticky rice into the mix of this mortar, which gave it that starch, which meant that, as the temperatures change, these rocks, they move slightly, they contract, they expand, they're in this huge structure, and that gave it a little bit of malleability. And there's these theories that the Romans used the blood of animals in some of their mortars because they believed that the blood helped protect it against frost. Now, I don't know of any kind of modern scientific investigations that have proved that.
Okay, yeah, so it's not been used in the Shard as yet. Okay, as far as we know.
It is used in firefighting foams, though. Firefighting, yeah. The horn and hoof, blood, bone, is one of the chemicals used on some of the firefighting foams, not the ones that we have in our homes generally, but yeah, the protein-based foams, because they're protein-based, they froth up, and that's what makes the bubbles. So when I was doing my research on bubbles, it stank.
Right. Helen, we've got onto bubbles. If you start talking about bubbles, we won't get to question number 2. And I know I like the fact that we normally talk about beautiful bubbles and we talk about wonderful and lovely bubbles. This is the first time that we've had stinking bubbles on, and Helen does not look best pleased. This is from here we are. Let's have a graphene question. This is from Des Morris, and Des would like to know, how are new materials like graphene going to change construction as we know it? So, Lucy, start with you. What is, graphene was an incredible moment of innovation and new understanding, wasn't it?
It was, but really not my field. The only thing that I really know about with something to do with the graphene, maybe carbon tubes, and hopefully we'll get a space elevator one day. But that's my knowledge on graphene.
Well, a space elevator, that's a good place, I think, to go. Helen, would you like to graphene?
Graphene was really interesting because it was what the brilliance of what they did was they took something that everyone had been doing for years. Like I and many other undergraduates had totally made graphene in our undergraduate courses, because when we were taught to use atomic microscopes as part of our undergraduate degree, we peeled off layers of graphite they basically did exactly the same thing, but they recognized, the clever bit was not that they did it, the clever bit was that they recognized that what was coming off really was different. And the thing about graphene is that it's this two-dimensional sheet of carbon atoms, but it's really strong and it conducts and it's light, and those are kind of holy grail characteristics. If you talk to a materials scientist or engineer, that's what everyone wants, right? Super strong. People like things that can conduct electricity and not being heavy. But the thing about graphene was it was sort of a solution in search of a problem. And there's University of Manchester had this great institute of graphene, and I'm sure they've done many great things. And the interesting thing about it is that it hasn't quite, I think it's still, someone's probably going to correct us on Twitter, hasn't quite matured yet, but it's clearly such a fascinating and brilliant thing that does something that no other material can do. But we haven't really worked out what to do with it yet. So there are some applications. And like Lucy was talking about, these high tensile strength cables might be one of them, although then you've got to scale up production of it. But I think graphene is, someone's going to get cross, but I think graphene still is a solution in search of a problem. So although it's useful, we haven't really found its magic moment yet.
So I think what Helen said is quite right, is that I think converting it from its theory into a practical material is what's the challenge. So I think about it being useful for the huge suspension bridges. So bridges can come in different forms. There's different ways that forces travel through our structures. And one of the ways that forces can travel is when you pull something. And that's why steel was really revolutionary when we could manufacture it on a large scale 150 years ago. And that's why bridges like the Brooklyn Bridge came up, because you could basically hang really heavy things from quite narrow cables. And so that's where I think this application of graphene could happen. But I don't know how you make such a kind of minute material work on that huge scale. So then the other possibility, which I think is being looked at for carbon rather than for graphene, just a different form, is using fibers within concrete mixes. So talking about horses again, there's a lot of, so the plaster actually you can see behind me, this building was built in 1995. The plaster on my walls has horsehair in it, and the horsehair basically binds the plaster together so that it doesn't crack very easily. And when we make concrete, we normally use these big cages of steel, but there are forms of concrete now coming up where they just mix fibers into the concrete. So it could be glass fibers, it could be plastic fibers, and then carbon fibers is another possibility. So that's on a much smaller scale. So maybe we'll see graphene on that sort of scale before we see them in big, huge things like bridges.
Have you got special plaster, or does all plaster from that period have horsehair in it? How do you know?
A lot of plaster from that era had horsehair in it. And one of the things I found out was, anthrax, which is like that bio-weapon type thing, that comes from horsehair apparently. And so when they do surveys of these really old properties, one of the things they often put in those surveyors' reports is, you may have traces of anthrax in your plaster because there was horsehair used in that era. So it's not unusual.
Yeah, I remember the university I went to, the second most flammable building, likely to, because of the and the first one was Hampton Court Palace. And while I was at the university, Hampton Court Palace caught fire. So we moved to number one spot of in the most possibly flammable building. This is, I'll start with you on this, Lucy. This is from Tracy. And she would like to know, what home gadgets do you think will be part of everyday life in about 10 years' time that at the moment most of us lay people have no idea about whatsoever? I know it's always hard, that kind of predictive, but when we look around at us now, and for those of us who are old enough to remember the early 90s, our landscape around our desks and is entirely different.
I think virtual reality is going to make a big hit in the next few years, particularly if we keep getting lockdowns, if this virus keeps coming. I think virtual reality experiences are going to become more of a thing. And so for now, virtual reality is mainly used in the gaming industry. It's also used in engineering for a bit of augmented reality. So you can actually overlay the drawing that you're meant to be looking at with the actual piece that has been manufactured and see it. But yeah, there's going to be virtual reality, I think, in most people's homes in the next 5 years.
Can I ask you, research has been done, but in terms of psychologically, the effects of virtual reality, because I'm thinking of the virtual reality we have in terms of social media, and we see what appears, I know there still aren't that many papers on this as yet, of really understanding how it does seem to have affected our critical faculties and many other things. And virtual reality, again, I wonder, whenever I've done those kind of things at conferences where you stick on the helmet and you walk around Guildford Cathedral or whatever, it's great fun. But do we know what's going on in terms of our brain at that point?
No, but I do know that if you smile and recount a story to me, it triggers the same parts in my brain as you are that it's triggering in yours from the memory. So you just telling me about your story triggers things in my brain. So I'm assuming that virtual reality must do something of a similar thing.
I kind of worry about virtual reality because it can be so close. So if you had, so for example, there's a lot of ship plans in Royal Museums Greenwich, and they have been digitized specifically so that games manufacturers who want to make virtual reality environments can actually use the original ship. So you've got a First World War, destroyer or something. You've got absolutely authentic replica of this ship. It's completely convincing. So what if you then sort of rewrite history a bit? Like, where does the human brain know that this bit is definitely a ship that came from a plan, and then this bit of history that looks so real because we've used all the authentic stuff, we're going to rewrite history a bit, or we're going to add in a dinosaur that probably wasn't there? There's this really interesting, what does it do to people's perception of what was real and what wasn't when those lines become so blurred? I don't know.
There's also that thing of, in real life you only get one life. In virtual reality, you can just reset the game.
Yeah, the Roma, what do you think in terms of perhaps what a lot of lay people like me would not expect necessarily will become domestic items?
So you might expect this, but because I'm a nerd, I had to get 2 show and tell items, not just the one. And this is a 3D printed model of a building, which has all these layers for a reason, which I won't explain right now. But I actually wonder whether 3D printers will become the thing that enter our homes. And one of the really interesting things about that was I went to see some researchers in the University of Berkeley. Lucy's pointing at her 3D printer, so she's way ahead of us. But I saw some researchers in Berkeley who were working on different types of resins that you could use to print stuff, and they were using waste from around California, so things like grape skins from the wine industry, and they were mixing this in with resins and stuff and basically creating a paste that you could 3D print with. And one of the things they were looking at was whether you could print off kind of this size, like a dish shaped or sized piece of 3D printed material, which had like hooks and things that you could then assemble to create a home. So they had created, igloo-shaped sized structures using this technique. But I guess it begs the question that if 3D printing became a lot more ubiquitous, that, we did it on sort of construction sites, or if I had a big, not even a big one, I could probably print off the things that I was talking about in Lucy's one. Could I actually print myself structures? And then to take that even like a step further, so completely off-piece from the question, they're looking at how to use 3D printing techniques to print structures in space, like on the moon and on Mars.
That's fantastic. I'm trying to remember, Helen, you might. There's one of friends has a 3D printed version of their skull, and I can't remember who it is.
Because is it Alice or is it Jim? I can't remember.
Maybe
is it Mark Lithgow? Because Jim and Mark Lithgow did that thing on Einstein's brain, maybe. Oh, I don't know.
It's such an interesting thing, that bit of getting a sense of your because I think of the first time that I saw a scan of my brain, and that bit of seeing interior you gives you, I think, a different sensitivity to existence and life, not merely the fragility of it, but just also that material nature of it. And I think the idea of each one of us being able to basically, hold our skull Yorick style, I think is an incredible possibility of facing up to what we are.
But there's a really interesting extension to this, which I've seen it. It's written. If anyone wants some reading, Cory Doctorow's Walk Away, I think it's called, is this utterly brilliant view of the future. But his view of these things is not just that everyone has a 3D printer, but what everyone also has is access to a list of where all the leftover things are. So say someone's discarded a car. You've got your 3D printer, but what you then do is you go and get the discarded bits and you recycle them into your new thing. So you need 2 things. You need the manufacturing capability, but you also need to know where the old materials are, because atoms just go round and round. And that's the thing, because I worry a bit about 3D printers. I mean, they're great, obviously, but you always buy new stuff. And what you want, obviously, is to be recycling old stuff. So I think that concept, and the book is utterly brilliant. It's absolutely amazing and slightly worryingly prescient. But that concept of you go and get your old thing, and then your machine turns it into a new thing, because you can download all the plans, you can download all the instructions. You can download where your thing is. You just have to connect those two things together. I think that would be a huge step forward.
The producer has got a question for you, and he was just wondering whether you have ever done a series at the European Space Agency where you've looked at 3D printers and the use of them in space, and it might be available on the Cosmic Shambles site. He just wondered if you'd ever done that.
He's got some strange ideas in his head, that Trent, hasn't he? Really. But yes, I can't remember which week it's out, but one of these weeks they were for exactly the reasons that Roma was saying, to find out how 3D printing works in zero gravity. ESA are doing experiments on that. I think it was a student experiment, that one, actually, PhD students. But yeah, because also the problem is with 3D printing on Earth, gravity's going to take the bit down, right? How do you do that when it might just float off? So there's some very serious problems with shifting 3D printing in space. But yes, the ESA series, which might theoretically exist on the Cosmic Shambles website, might answer some of those questions. Theoretically.
That episode might not be out yet. Lucy, sorry, you wanted to add something as well.
Really a similar thing. So the company Made in Space have sent a 3D printer up into space, and they've 3D printed ratchets and all sorts. But they're now looking at recycling. So you make this is my iPhone stand. So you make something like this, and then maybe you don't need it again. And so they're looking at how do we chomp this back into the small bits that make the filament that go back in. So it's making it a circular economy, which in space is really rather needed, because getting anything up into space is very expensive. But again, it's great for use on Earth for recycling.
Now, it's interesting. We'll almost stay on space now. This is from Raj. You mentioned space, elevators into space before. And Raj would like to know, is there a theoretical height you couldn't build a building taller than? So let's start with you, Lucy, or I can go to Roma, whichever you...
My answer is yes, and I don't know how high it is.
That's a very good start. I throw straight over to Roma now.
So I find this question really difficult to answer in some ways, because I want to say that the science and the engineering can always solve the problem. So, and we can always say, well, how much money do you have? Because it's about expense. It's about where do you do it? It's, kind of the practical problems rather than engineering limiting us. But I think it's a lot more nuanced than that. And I think the money is a huge thing. But the second huge thing is, like, what do we as humans actually want? So just to get a little bit philosophical, the taller buildings get, the wider the base gets, because it's more stable. So what does that mean? That means you don't get as much natural light coming into the interior of the building as you would if it's, a smaller building. And the Shard is a really interesting example of this, because it's a tapered shape, and the offices are in the lower part of the building than the hotel rooms. So that in offices, it's not as important for you to get daylight throughout the whole floor, but in a hotel room, every room should have daylight. So you build these like a huge mega tall, massive structure, but you might not get much daylight in. And then you want to think about actually living up there. So how long would it take you to get the lift up and down? So you want to pop out to the shops, but you realize you've forgotten your phone upstairs. So what's the actual kind of practicality of it? So I think that the heights that we will stop building at is to do with humanity and the way we live, rather than what technology is restricting us to.
Well, wasn't there something that the thing that set off one of the things that made possible the skyscrapers in New York was the invention of the elevator, because people didn't want to walk up all the stairs.
Exactly. I write about this in Built, actually. So I talk about the fact that in Roman times, they used to build these apartment blocks that were called insulae, and they were up to 10 stories tall. So apartment blocks in some ways can go back 2,000 years. But the most expensive apartments were at the base of those apartment blocks, and the cheapest ones were at the top, which is kind of the reverse of this idea of being in the penthouse or the loft at the top of the building. Exactly for that reason, because they didn't have to climb steps, A, and B, sewage needed to be carried out of your apartment, and if you lived downstairs, it was much easier to just kind of chuck it out the front door. So that was definitely why Insulae stopped at the levels they did, because people just couldn't climb anymore. And it was only when it was an engineer called Elisha Otis that invented the lift with a brake in the I'm going to get the dates wrong, but 1850s, 1860s, that they decided like, oh, wow, we can actually build skyscrapers now. So the first lift he built was in, I think it was a 5 or 6 story building in Manhattan. But basically from there, they've gone everywhere. And the Burj Khalifa, which is the tallest building in the world today, has got lifts that say Otis in them, which is the company that Elisha Otis set up 150 years ago.
Brilliant. We've not got long left. So the good news is, Helen, we've got a bubble question as usual this week. This is from Arav, who's 6 years old. And Arav would like to know how soapy water makes bubbles.
So soapy water is very good at making bubbles. The way it makes it, so water by itself has a surface which is always trying to shrink. So if you leave a drop of water all by itself, it will shrink into a sphere and you'll never make a bubble. But what the soap does is it's made of molecules that have an end that likes water and an end that hates water, and they sit on the surface. So you have a water surface and it's got these little molecules that have a sticky out bit on either side. And what it means is you can create a thin film of water, but it's protected by a little coating of soap molecules on both sides. And because they cover the surface doesn't feel that it needs to retract anymore. So when you blow a soap bubble, what you're doing is the surface coating of soap protects the water. So as you blow the soap bubble out, it's got a protective coating of soap on the outside, a protective coating of soap on the inside. And then when they join together, you get this beautiful spherical bubble. So it's all to do with the soap hiding the water surface, but it only works because it's got a layer of soap on the outside and a layer of soap on the inside, which is why if you want to stick your finger into a bubble without popping it, you can do it, but you can't do it if your finger's dry. You have to dip your finger in soapy water, and then the soap on your finger joins up with the soap bubble, and so you can put your finger into the soap bubble without popping it. So as long as you keep that protective coating over the outside and inside of the bubble, then the bubble can exist. But if those two protective coatings ever touch, you get a hole and then it's all over. The bubble has burst.
Brilliant. Thank you, question, Arav, as well. We're all pretty much out of time, so they almost be yes/no answers on this. This is from Mark Norris. Does the panel think that we will ever develop a propellant-less space propulsion system to react directly on the vacuum? So that's yes or no, Lucy?
Yes, slingshot.
Okay, slingshot. So and you're, because I mean that is incredible. The slingshot idea, and I'm trying to think which there's the fastest. Well, I'm trying to remember when we were doing a show with astronauts the other day in terms of the use of slingshot for the furthest distance that we're going to be able to travel. The project that's on at the moment. I'm trying to remember which it is. Is anyone any good on this?
I don't remember.
No. Anyway, I'll look that up. I'll answer that. There's something next week as well, which I was just one of the. I think Rusty Schweikart was talking about the use of slingshot for certain space missions that are coming up. What do you feel, Roma, about propellant-less against the vacuum of space?
No idea.
So yeah, the bridge is still the way that we're going to generally join up the solar system, I presume. And I've got a weird question here, but it's weird because it basically says you'll understand what this is, Roma. I think $10 man equals Tacoma Narrows equals and then more than sign Golden Gate. Any idea?
I don't know what the beginning bit means. The Tacoma Narrows was a bridge with, one of those suspension bridges that I described before. And that collapsed in a relatively light wind because the way the wind was flowing around the structure kind of set off this resonant reaction. And I mean, if you can just Google or look on YouTube for a video of the Tacoma Narrows, and you can see this kind of concrete bridge kind of literally waving around in the wind, and then it collapses into the sea. So definitely hope that the Golden Gate Bridge doesn't go that way. The Golden Gate Bridge has done quite a lot of galloping which is what this phenomenon is called, in really high winds, but it's still doing quite well.
Do we know that because was it in China where there was that glass bridge built where you could look directly below, and basically because there's a small version of that in the San Francisco Museum of Modern Art, and that's fine because it's only about 4 steps. But it appears that there is something psychological. Once you go beyond 10 steps, your brain reacts. It doesn't matter that you logically know this is solid. Your brain looks at the ability to see all the way down to the valley and goes, no. And as far as I remember, do you remember this, Helen? There was a lot of...
Yeah, I do. But it's interesting. But it's interesting because it's a really sort of that thing of suspension of disbelief, because in material terms, there is very little difference between a transparent material like a glass and some other things you might make a bridge of. It's just that light happens to go through one of them and doesn't happen to go through the other. It's interesting because it's nothing to do with the structural properties of it, really. Yes, there are some differences in the way glass responds, but fundamentally it's a ceramic, and it just happens to be transparent. And I just find it really interesting because I've been even on like London Bridge and places where there's these little, it's not even 3 steps and people are edging around the side of them, and yet they walked up there in the first place. It's the psychology of that is really interesting, but I don't know. I don't remember how big the bridge was. I do remember it made a lot of people very unhappy.
I mean, literally nauseous and.
But is that not something you can train your brain to do? I've been learning to slackline this week. I say learning to slackline. I can now stand on it for at least 5 seconds as opposed to a fraction of a second. But it's my brain that was setting off my legs going all wobbly to start with, and I've trained my brain and my body, but people tightrope walk over canyons where
it's a learned thing. Yeah, I used to be a springboard diver, and I would do it every week. But if I stopped doing it for even 3 weeks, it would my brain, the fear thing would kick in again. I really and it would take a while for me to. Because you've got to have confidence to do that. It's not enough to do it. You've got to do it with confidence. And it's a surprisingly short period of time, even as a regular diver, that it took to lose that little bit of I'm completely okay with what I'm about to do. So it is very much a learned thing.
Also, there's a danger you end up in that wily coyote across the cliff and then just stops for a moment and then has that realization. If you become a little bit too blasé, eventually you will walk halfway across the valley and then go, oh, this isn't an invisible bridge. That's... so.
He always survived, though.
Oh, that's true. Never happy, but always surviving. Isn't that what a human coyote he was? This Roma Built is available now, isn't it? In paperback, I believe.
It is. I've also got a podcast. I did 3 episodes. It's called Building Stories. So if you want a little taster of the kinds of things I talk about in my book, then you can go ahead and download that. But yeah, get the book. You've got loads of time to read at the moment, clearly. So
brilliant. No one's got any time to read. Every person watching this is taking a break from making their own podcast. There are now more podcasts than there are human beings. I don't know how I'm going to keep up with it. Lucy, Helen, rather, your book is still available. Still in a teacup.
Yes, and I'm doing so. The other thing I've been doing a bit of is a podcast. As you say, everyone is doing a podcast. So Royal Museums Greenwich. So nosing about on the inside of the museum. So that has been Ships, Sea and the Stars. So if you're curious if you're missing museums, we are doing one of those every week, and we are nosing around inside of all sorts of subjects with experts inside the museum. So that's my little plug for the week.
Brilliant. And Lucy, what you're doing of the podcast? What are you going to be explaining to us? Now you've got quantum computing out of the way.
I don't know if actually that one's gone live yet. So look forward to that one.
So what's the next one you're going to be recording?
Not sure if we've gone public yet, but I'm really hoping that the Engineering Edge is going to make a comeback for a series 2. And that's where I look at everyday technology that gives people the edge. So I looked at Black Gang China theme park that are using Raspberry Pi computers, little 30-pound computers, to control their robot dinosaurs, where those Pi computers weren't designed for that. So looking at areas that are using technology from maybe one place in another place to give them an edge.
Oh dear, this has got a Michael Crichton novel written all over it. What do you mean we use the $30 dinosaurs are out of control? So Jurassic Park meets Westworld in your life. Thank you very much, everyone, for watching this. Thank you so much for your questions. I think we got through nearly all of them. If not, if we might have even got through all of them this time. And thank you very much to Roma, Lucy, and Helen. Helen and I will be back at 3 p.m. next Sunday. Go and look up all of their work. They are all online, and they're all people who are always kind of broadcasting interesting ideas and things which, when you're sometimes trapped in a mire of the preposterousness of our politics, looking in the world of technology and engineering can give you a level of hope with humanity, I think. We will be, as I said, Josie is on tonight at 8:30, I think it is. 8:30 tonight. She'll be doing on the Shambles channel. She'll be doing her show Tender. We've got more show and tells, and I think the latest book Shambles at the moment, I'm trying to remember which one, but the one with Tori Amos. That's great. It's Brian Cox, for once, has been envious of me. There's nothing he's being envious of, but the fact that I did a podcast with Tori Amos and he didn't, it appears that I have the lead for this week. So keep up to date with our show and tells, our book Shambles. As I said, there's a tip jar at the bottom here. We're using that to try and help keep funding some of the artists, etc., who at the moment are unable to do any of their live gigs, which is their bread and butter work. And also, if you are able to support us via Patreon, that's how we make all of these different shows, the documentary with Helen and Ginny on the European Space Agency, all of the other stuff we do. Thanks very much for watching and or listening, if you've been listening to it, or doing a little bit of both, kind of being preoccupied with other things as well. Anyway, bye-bye.